This is the first lecture for Chem E 115. What I wanted to show on this diagram is one process of thousands that you could be working on after you graduate. This process involves the use of corn stover, the plants, to produce ethanol. So the final product is ethanol, which is used for fuel. And this plant involves building energy through a powerhouse, and it involves recycling water. So there's recycle steps, and there's also reaction with enzymes and with fermenter, and there's also recovery and so purification. So this is one of many plants that you could be doing when you graduate and get that job you're dying for. And so this is something, we're going to learn about all these different parts in this class. We're not going to learn the details of how the different parts, the unit operations are called unit operations. We're not going to learn the details of how they function, but we are going to learn how to balance the equations of the materials and energy going into and out of the processes. So for today's lecture, we are going to cover basic terms and units. And so a lot of this is just, a general introduction to chemical engineering. So I'm just going to review some of these principles like thermodynamics. Some of these you've seen before, temperature, pressure, and volume. And we're going to look at specific volume, density, and concentration. We're going to learn about specific gravity and get a review of the ideal gas law. We're going to look at basic concepts of work and heat, specifically about expansion work. We'll review force, and we'll review kinetic and potential energy. And from this, these are review of concepts, and a lot of this you've seen already. But so it's really important that you make sure that you are well versed in these topics as we proceed in the course. So very important in chemical engineering, the same way that we have atoms in all materials, the units of every number in chemical engineering should have units or else be specified as dimensionless. And we need units because the units form the basis of our calculations. So it's the same way when you speak a language to people. There's the word the in English, and you have to know how to say the. In different languages, you say it in different ways. And it's the same way with the units, that different parameters and values have different units, and we combine them in appropriate ways based on their units. Okay, so a dimension describes something that can be measured, okay? And examples are length, time, mass. These are dimensions. Note this is not the same thing as units, okay? A unit would be something like kilograms or meter cubed, which describes mass. This is a unit of mass and a unit of volume. So the different subjects that you will be learning in chemical engineering, we will learn about the driving forces to make processes happen, which is thermodynamics. And we will also learn about the resistances, which thermodynamics doesn't tell us how long it takes for things to happen. But the resistances to the process change will tell us how long it takes. And these are going to be included in fluid transfer, which you're going to be learning in Chem E 190, mass transfer, heat transfer, which you'll be learning in Chem E 190, and kinetics you will learn next year in Chem E 158. In the spring and in the fall, you will have unit operations. And next year in the fall, you will have reactor design. And next year in the spring, you will have process control. And you will also have a class on safety and ethics, Chem E 161. And you may be taking that this fall, or you take it next year in the fall. Okay, so let's review thermodynamics. As we said in the previous slide, thermodynamics describes driving forces that enable processes to occur. Okay, so thermodynamics also gives us a set of principles, which we know, like conservation of energy, that allows us to determine the state of a system under a given set of conditions. What does the state mean? State means the temperature, the pressure, whether it's a liquid or solid. Those are those describe the state of the system. Thermodynamics also helps us determine the limits of safe operating conditions. So we need thermodynamics to be able to determine how safe a process is. Okay, we can also know whether a reaction will be spontaneous and which direction it will go. But as I said, it does not tell you anything about how fast the process will occur. So the resistances, okay, is involved with the subject of transport phenomena. Okay, so in transport phenomena like Chemi 190, Chemi 160A, and Chemi 160B, you will be studying resistances. And here's the relationship. The rate of the process is going to be the driving force divided by the resistance. So this is all of your transport phenomena, and this is your thermodynamics. So as we said, this is one example, okay, for heat transfer. Rate is the driving force divided by the resistance. The driving force for heat to move, which is actually energy is moving as heat, which is crossing a system boundary. The driving force is the difference in temperature between two bodies. So we know that heat will flow from the higher temperature to the lower temperature. And the resistance is this relationship here, okay, which is thermal conductivity, the area, and the distance, okay? And combined together, those will give us the rate of heat transfer. So let's move on now. These are basic units that you need to be using in this class. We use a lot of them. I'm sure you're all looking at this and being relieved because you've seen it before. All right, so pressure is the force applied by the system perpendicular to the area. All right, and we have units of Newton over meter squared, which is this also called the Pascal, and this is the SI units. In English units, we have PSI, or pound force per square inch. All right. Another state variable is volume, which is the space taken up by a substance. Here in the SI units, we have meters cubed. The liter is the same as a decimeter cubed. And in the English units, we have foot cubed. Okay, temperature is described as the degree of hotness of a substance. And the SI units are Celsius or Kelvin. In English, we have Fahrenheit or Rankine. So I'm going to say this now, and I will repeat it. But when you're looking at absolute values of temperature, it matters whether you are in Fahrenheit or Rankine, or whether you are in Celsius or Kelvin. But if you have a delta T, then they have the same units. Okay. So let's look at some very basic calculations. The specific volume, okay, is the volume divided by either mass or moles. All right, so specific volume, okay, and it has a hat over it in our book, okay, V hat. So it has units of volume, such as meters cubed, divided by unit mass, which could be kilograms. Okay, so the SI units are meters cubed per kilogram. CGS units are centimeters cubed per gram, and English units are foot cubed per pound mass. Okay. Specific volume can also be written in terms of moles, the meters cubed per mole, or meters cubed per kilogram mole. Density, on the other hand, is the inverse. Inverse meaning 1 divided by the specific volume. Okay, so density has units of mass per volume. All right, we have come to the end of this lecture, and you have an assignment to go to do this quiz, and it's video quiz 1.1 in Canvas. So you should log in there and complete the quiz before the beginning of the next class period.